Hi guys, this video has been put together for you about the history of the atom, and it covers a whole bunch of different scientists who have helped us understand what atoms are made from. This has been put together by Miss Morrish. Enjoy, here it comes.
Hi Year 9, Miss Morrish here. I noticed I was going through some of your quizzes that you've done so far for this week's lessons on the National Academy content that were really struggling on the history of the atom, particularly with the alpha scattering experiment. So I wanted to go through some of the information for you to kind of make things a little bit clearer for you. I'll be skating over the majority of the timeline of the history of the atom, spending most of the time on the alpha scattering experiment. Okay, so first off, we had Democritus. He was a Greek philosopher, and he was the first person to disagree with the idea that the entire universe was made up from the 5 natural elements, being earth, water, fire, air, and something they called ether. Instead, Democritus proposed that matter was made from small, indivisible parts that he called atomos, or atoms, and that's where we get our modern name from. Now, he said that these atomos could not be halved forever and eventually would not be able to get any smaller. Okay, so we had Democritus back in the ancient Greek times, and then for almost 2,000 years, our idea of the atom never changed until we get Charles Augustin de Coulomb. You might recognise the term Coulomb as the unit of charge that you may have encountered in your physics lessons previously. Charles Augustin de Coulomb in 1785, he came up with the theory that opposite forces attract. Now, this is something that we're quite familiar with at the moment, and it's something that we have been using a lot in our previous physics lessons. But this was the time that the idea first kind of came around. Although he didn't actually come up with any atomic theory himself, he did help other scientists when they discovered that parts of the atom were either positive or negative, and it really helped to kind of develop those theories. Okay, so now things are really kicking off in the world of atomic theory. In 1808, John Dalton confirmed the view of Democritus and stated that atoms are tiny, solid balls, a little like a billiard or a snooker ball. Although he didn't change the idea of the atom, he did write down the first ever atomic theory. He stated, first off, that atoms are tiny, invisible particles. He also stated that atoms of one element are all exactly the same. Atoms of different elements are different themselves, and that compounds are formed by combining atoms. Now, this is the first time that any of these ideas have really kind of come together. So we're looking at different types of atoms of different elements joining together to make compounds and new substances. And this was the first time that this had ever been recorded. So this is a really big part of the history of the atom. Right, okay, so 1897 comes along, almost 100 years later, and here we get J.J. Thomson. Now, he discovered the presence of electrons, and he identified that electrons could be removed from the atom. So because of this, Thomson suggested that the atom was a sphere of positive charge with tiny electrons stuck in them, kind of like fruit stuck in a pudding. Now, this coined the term plum pudding model. This was a huge development in chemistry and physics at the time, because it completely changed the idea. So we were still looking at these tiny invisible particles, but now there was the idea that this particle was made up of more than one type of thing. So we knew we had a positive charge, which was like the pudding part of the plum pudding, and then these tiny negatively charged particles he called electrons that were randomly stuck in. This built on for later models of the atom, building upon this idea that we have more than one charge. Okay, so now we come on to Ernest Rutherford and his published work in 1909. Now, this is the part that a lot of you were really struggling on, and this is something that comes up in exams quite a lot, so it's really important that we understand what happened and the implications of the results of this experiment. So what he did was he got a very very thin piece of gold foil, and at that gold foil he fired a beam of alpha particles. Now alpha particles are positive because they are made up of just the nucleus of a helium atom, so it is 2 protons, which are positively charged, and 2 neutrons, which are neutrally charged, giving an overall charge of an alpha particle of +2. So what he did was he fired these particles at the gold foil and he observed where they came out the other side. So based on the plum pudding model, the alpha particles should have passed straight through. However, this isn't what happened. Most of the particles did pass straight through, as was predicted. However, some were very slightly deflected. As you can see on the diagram at the bottom on the right hand side, we can see the third arrow from the bottom slightly deflects off to towards the bottom of the atom, and some of them were bounced backwards completely. Now this disproves the previous model of the atoms of plum pudding. So what Rutherford decided was that the majority of an atom was in fact empty space, which allowed the majority of the alpha particles to just pass straight through. But we have most of the mass of the atom was concentrated at the centre in a tiny nucleus. Now, because of the work of Charles Augustin de Coulomb with the idea that opposite charges attract, and like charges repel. Now this must mean that because of the nucleus of the atom deflecting away the positive alpha particles, this must mean the nucleus itself has a positive charge. Therefore, the nucleus is made up of protons. So this was really important. It completely redesigned the model of the atom as we know it. So you need to understand the idea of these positive particles bouncing off of the positive nucleus of the atom because like charges repel. Now, depending on how close to the nucleus of the atom these alpha particles pass, depends on how far it deflects. If it doesn't pass too far within the field of positive charge, then it will only deflect slightly. However, if it's fired directly at the nucleus, it will be deflected a lot. Imagine putting 2 magnets together where you have both north poles facing each other. The further away those 2 magnets are, the less you can feel that repelling force. However, the closer you put those 2 magnets, the more you can feel it, the more that force is pushing away. And that's very similar to what happened to the alpha particles within the alpha scattering experiment. Okay, so moving on, not too far to be honest, we get Niels Bohr publishing his work in 1913. Now, Bohr was unsatisfied with Rutherford's model because of the idea of the positive charge in the middle, and electrons floating around in a cloud would, according to Rutherford, mean that the negative electrons would be attracted to the positive nucleus, again following on from Coulomb's work. Therefore, Bohr stated that the electrons must orbit the nucleus of the atom at certain distances, or in shells, much like the planets around the Sun. Now this would make sense because if the electrons were not held within those particular energy levels or shells, Bohr was correct. Those negative electrons would 100% be attracted towards the positive nucleus of the atom. However, we know that that doesn't happen, so there is something holding those electrons in orbit in energy shells. Okay, now we have James Chadwick in 1932. Think about it, it's actually not that long ago that we were still kind of building upon the model of the atom. So in 1932, James Chadwick was able to solve the problem surrounding the actual mass of an atom being approximately twice what it should be, according to the number of protons in the nucleus. So what he did was he came up with the idea of neutrons. Now, he stated that neutrons were a neutral particle in the nucleus of the atom. This would make the atomic mass of the atom accurate without affecting its charge. So that's what he came up with to solve that issue, and it appears that he was correct. Now, moving forward with scientific theory and experiments, we are constantly revising scientific theories based on more evidence. Now, just because we are kind of pretty happy with the model of the atom as we have it today, protons and neutrons in the nucleus in the centre of the atom with electrons orbiting in energy shells, energy levels at certain distances, doesn't necessarily mean that we are 100% correct. In however many years' time, we may come up with new theories based on scientific evidence. Now, that's how science has developed throughout time, and it's how it will continue to do so. So it's always really exciting to keep an eye on any new scientific discoveries which happen. Loads have happened during our lifetime so far, so it might be a good idea for you to maybe have a little Google and see what you can find. Particularly interesting is the work on photographing black holes, the Mars rover, and things like that. Okay, now that we have looked at the timeline of the history of the atom as we know it, it's time to have a little look at some questions which you may be asked about this. Now, it's very common for these questions to turn up in the exam, so it's important that we know how to tackle them. So here is a typical question. Draw one line from each description of the atomic model to the stage in the development of the atomic model. What I would like you to do, please, is to just pause the video and have a go at matching up the boxes on the left-hand side with the box on the right-hand side. You must only draw one line from each of the two boxes on the left. So pause the video and have a little go, and we'll mark it in a moment. Okay, so if you can get your green pen ready, we're going to mark this now. So what we're going to have a look at first is a ball of positive charge with electrons embedded in it. Now that was the plum pudding model. So give yourself a nice big tick if you've got that correct, or edit it in green pen if you didn't get it right. Spherical atoms, right at the bottom there on the left, was a Dalton atom. So that was before we had built up the rest of these theories surrounding a nucleus or electron shells or things like that. Okay, so now here we have a slightly longer answer question. This is a question that is worth 4 marks. We have a beam of electrons, neutrons and protons travelling at the same speed is passed through 2 oppositely charged plates. The diagram shows the directions of 3 particles after passing through the charged plates. The charges on the electric plates are not shown. The heavier the particle, the less the deflection meaning how far it is moved off course. Explain which directions the electrons, neutrons and protons will take. So for this question you need to think about the idea of charges, how big the particle is or how small it is, and think about particularly the charges of each of the 3 to decide whereabouts they would go. So 4 marks, 4 minutes, pause the video and have a go at answering this question, and then we're going to mark it. Okay, green pens at the ready. So particle A was the electron. Because it has less mass, it is deflected more. So if it has less mass, it's going to take a lot less force to make it deflect further. Or you could have said that the electron would be deflected towards the positive plate because it's negatively charged, again using the idea of opposite charges attract. Particle B was a neutron because the neutron's path does not change as it is charged. Remember, neutrons are neutral. The 2 parts of that word get fit together to help remind you which charge it is. Neutrons are neutral. Particle C, therefore, was the proton. Now, the proton has a greater mass, so it is deflected less. Remember, the relative mass of an electron is approximately 1 over 1,800, and the mass of a proton is 1. So, proton has greater mass, therefore, it is deflected less. Or you could have said that proton is deflected towards the negative plate because it is positively charged. You could then go on to say which of the plates is positive and which is negative. We can say that the upper plate is positive because the electron has been deflected towards it, and the lower plate is negative because the proton has been deflected towards it. Okay, now that is it for the feedback on this lesson. So what I would like you to do is have a little think about any questions that you might have. Feel free to drop me a comment on showing my homework or leave me an email. I don't mind either way. I have also set up Microsoft Teams for your class, so if you would like to send me a question on any of those, please feel free. I hope that you have found this useful and enjoyable. Thank you very much, and as ever, stay safe.